Hello, I'm Mrs. Arnold, and today we are learning about the causes of earthquakes. This is going to coincide with Chapter 19, Section 1. So the main idea of this video is that faults form when forces acting on rocks exceed the rock's strength. So we are going to be able to answer how are stress and strain defined as they apply to rock, what are the three types of movement of faults, and what are the three types of seismic waves by the end of this video. Along the boundaries between two tectonic plates, rocks in the crust often resist movement, and over time, this is going to cause a buildup of stress. Stress is a force. It is the total force acting on crustal rock per unit area. And there are three types we're going to talk about. First one is compression. The other one is tension. And then the final one is shear. The types of stress, once again, are compression. So compression is going to cause material to shorten. And you can see that it is a squeezing force because the rock is being pushed together from both sides. Tension is going to cause the material to lengthen. In this case, the material we're talking about in all of these cases are rocks. And this occurs when the forces are acting against each other. And then we have shear, which causes a distortion of material. And this is when we have the force working past each other like this. And the other thing I want to define is strain. This is what we call it when we see materials deform. So this is a deformation of materials in response to stress. So we see strain in response to the stress of compression, in response to the stress of tension, in response to the stress of shear. So rocks can be twisted, squeezed, and stretched, but they fracture when stress and strain reach a critical point. At these breaks, rocks can move, releasing energy built up as a result of stress. And earthquakes are going to result. So earthquakes are a result of this movement and release of energy. So there are two different types of deformation. You can see this chart. This is a stress versus strain scale. And when we have, when we're first looking at stress and strain, and as stress is increasing, we can see right here that we are encountering elastic deformation. Elastic deformation is something that the rocks can bounce back from. But the definition is It's cause under conditions of low stress when rock is compressed, bent, or stretched. And with elastic deformation, as I mentioned, it returns to original shape when the stress is removed. So when that compression is removed, or that tension is going to return to its original shape. Now, if we keep going up this curve, you can see there's an elastic limit. Past that elastic limit, that is where we see plastic deformation. This is stress that builds up So stress builds up past the elastic limit and causes permanent deformation. So even if the stress is removed with plastic deformation, it's permanently deformed. A fault is going to be any fracture or system of fractures along which Earth moves. So crustal rocks are going to fail when stresses exceed the strength of the rock, as we saw on the last slide. Right here, this is failure. Once the stress overcomes the strength of the rock, then they fail. And then that results in movement along a fault line. And a fault is any fracture or system of fractures along which the Earth moves. We describe faults using the footwall and the hanging wall. The footwall is going to be the side that you can climb up using your feet. That's how we can look at it. So if you look here on this picture, I will use yellow to differentiate between the two walls. And I'm not going to trace it that well, but this is the fault right here. So this side is the footwall. And remember, that is the side of fault that looks like you can climb it with your feet. And then the other side, which I will do that like that, this is the hanging wall. And that is because this is the side of fault that you will have to climb by hanging on a rope. So it's important to understand how a hanging wall looks and how a footwall looks, because that is the different ways we're going to describe the different types of fault relative to the footwall and the hanging wall. So it's good to remember these definitions. The first fault we're going to look at is the reverse fault. This fault is seen near convergent plate boundaries. At these faults, the rock is squeezed and crust is shortened. So that tells you that the stress that it undergoes is compression. Also at these, you see that rock on one side of the fault, which is the hanging wall in this instance. So the hanging wall is pushed up relative to the footwall. And we can see that happening in this picture. So with a reverse fault, this hanging wall is going to be pushed up relative to the foot wall. So the stress is compression, but because of that compression, the hanging wall is going to go up relative to the foot wall. So after the faulting, the two areas are going to be closer together. Okay, next we have a normal fault. With a normal fault, the rock is pulled apart and stretches the crust. So the opposite of what happens with the reverse fault. And so also that is the stress, there is tension. And we see the opposite happen then. So the hanging wall moves down relative to the wall, as you can see in this picture. And at the end then, the two areas, a normal fault would be farther apart after faulting. So this is a picture of a normal fault. We can tell because this here that I'm outlining is the hanging wall, and it has moved down relative to the foot wall, which is on this side. And that means that this is a picture of a reverse fault. So we can tell that because this is the hanging wall, and you can see that it is over the foot wall. So going to be caused by the third type of stress we talked about, shear. So this is caused by horizontal shear. And the movement at these faults is horizontal and in opposite directions. And an example is the San Andreas Fault in California. So this table you can find in your book. It is just a summary of the 3 different types of faults that we went over. The reverse fault, the movement of the reverse fault is going to have compression, pushing them together. We see vertical movement upward along the fault plane. It's particularly by the hanging wall. Normal fault is tension, so they're being pulled apart, and we see vertical movement downward by the hanging wall. And then shear is horizontal movement along a fault plane. Strike slip, is shear occurring along a horizontal movement. Okay. So earthquake waves, we have seismic waves, which are vibrations of the ground produced during earthquake. And every earthquake has 3 types of waves. We have primary waves, secondary waves, and surface waves. Primary waves squeeze and push rocks in the direction along which the waves are traveling. These are also known as P waves. And you can see that the particle movement is pictured here. So the rock is being squeezed and then moved. Secondary waves are also known as S waves. These cause the rocks to move perpendicular to the direction of waves. So the wave direction is that way, but the S waves are going to move perpendicular to the wave motion. And these are slower than P waves. And so they are the second set of waves to be felt. And also that explains why they are called secondary waves. The last wave is the surface waves. These only travel along Earth's surface, and this is the slowest type of wave. And you can tell that the particle movement here is in a circular fashion. So where and how do these seismic waves generate? They generate at the focus. So the focus is going to be the place where the rock initially fell. So this is the point of initial failure. The point of initial fault failure. And then the epicenter is going to be the point on Earth's surface that's directly above the focus. So in the picture, the yellow is the focus, which is the initial fault failure, and then directly above that, that's the epicenter. So today we learned about how different types of stress causes faults, which cause earthquakes. We also learned about the waves that are generated during earthquakes.